Hello, everyone. Welcome. We are just taking a few minutes to let all the participants arrive. So get comfortable, and we're going to start in a minute. Thank you so much for being here today. There's a lot to talk about, so we're going to start on the dot, but we're going to leave some time for everyone to arrive. You still have time to get a glass of water or a cup of tea. Thank you so much for being here today. Make yourself at home. And yes, feel free to say hi, introduce yourself in the chat if you have already joined us. Right, so yes, we are on time. And hello, everyone. Hello and welcome to the event, The Toxic Toll of Waste Incineration, Measuring Health and Environmental Impacts. My name is Maria Vilella, and I'm the director of the Global Climate Program at Gaia, which is the global alliance in which Zero Waste Europe serves as a regional network. For those that don't know our organization, Zero Waste Europe is a Brussels-based NGO working on advocacy at the EU level, and it's also a network of organizations implementing zero waste strategies at the national and local level across Europe. Today I will be moderating this event, so let me introduce you to the webinar tools. We have the chat box, and I see a lot of people already introducing themselves. Thank you so much. Welcome. And please, for those that are arriving now, yes, introduce yourself using the chat function. And for questions, please submit your questions via the Q&A tool, which is going to be in your toolbar in your Zoom window. And I will then take these questions and pass them on to the speakers so that we save time. We are also streaming this webinar in YouTube, so anyone watching us through that channel can submit the questions there. And without further delay, let's start this important discussion by giving the floor to Maria Soraya, member of the European Parliament, for the keynote remarks. Maria Soraya? Yes, thank you so much for joining us today. The floor is yours now.
Thank you, Maria. Hello, everyone, and welcome to this webinar on the toxic toll of waste incineration. Firstly, allow me to thank the organizer, Zero Waste Europe, and my colleagues, Martin Hausig, for co-hosting in this event with me today. As you may know, waste incineration has grown steadily. Since 1995, the amount of municipal waste incinerated in the EU has risen by 31 million tons, or 105%, and accounting for 60 million tons in 2020. Waste incineration is often presented as a clean and safe way to make our waste disappear. Yet, during the incineration process, many pollutants dangerous for human health and the environment may be emitted into the air. These are the so-called forever chemicals, organic pollutants that are resistant to environmental degradation through chemical, biological, and photolytic processes. And these chemicals can be transported over long distances. Because of the transboundary behavior of persistent organic pollutants, international treaties are required to regulate, mitigate, or even eliminate toxic chemical emissions. Nevertheless, to say, stringent implementation of the regulation and monitoring is needed to guarantee safety and health. However, loopholes still exist in national and international regulations, resulting in an underestimated registration of persistent organic pollutants. This webinar will look into growing public concerns over the potentially toxic effects of persistent organic pollutants on human health and the environment. We will listen to the presentation of the report based on biomonitoring of pollution around waste incineration in Czechia, Lithuania, and Spain. This report analyzes the presence of persistent organic pollutants in chicken eggs, vegetation, and masses in the surroundings of incinerators. We will be reminded that this problem is not limited to these 3 cases studies, but it is an EU-wide issue. Lastly, we will discuss actions to limit incineration in line with the EU Zero Pollution Action Plan, examining the possibility of including other chemicals in EU legislation. As policymakers, we need to reassure compliance with EU regulation, guarantee safety, and mitigate potential health risks of chemicals. We will hear the views of different stakeholders on whether the current monitoring of forever chemicals is for purpose. I think we need to explore opportunities in the upcoming revisions of the waste shipment regulation and the industrial emission directive expected in April. And now I give the floor to Mr. Abel Arkenbout, Head of Research, Toxico Watch Foundation, who will present this very important report. You have the floor, Mr. Abel.
Okay, thank you.
Okay.
Okay, thank you for your nice introduction. I'm Abel Arkenbout from the Toxico Watch, and we have done this research of biomonitoring research in 3 countries. Wait a moment. The outline of this presentation will be at first an introduction in sustainability to the findings of this biomonitoring, 3, the loopholes in the European regulations, and 4, the limited analysis. The 5 point is the exclusions of ODNOC, or better said, other than normal operation conditions. And the 6, we do some recommendations. When we look to the promotion leaflets of incinerators, if you look at the Czech Republic or Lithuania or Spain or even in the Netherlands, all the leaflets are colored nice blue and with a perfect harmony with the nature. All is sustainable and there's no pollution in the air. And this at the left side is our main topic of research, that is the incinerator in the Netherlands, in Harlingen. And we have done more than 20,000 hours at research at this incinerator. We find a lot of dioxins coming out of the chimney and a lot of dioxins in the environment. But in 2019, 2020, this incinerator was awarded as the most sustainable company in the Netherlands. So it makes us a little bit wondering about the definition of sustainability. Because these are the results of our biomonitoring research around waste incinerators. What we find are toxic eggs, toxic vegetation, toxic trees, and that we found in Kaunas, in Lithuania, in Madrid, in Spain, and in the Czech Republic. We go now more in details of the results. Wait a moment. In the middle is the incinerator, and we make a circle of 2 kilometers. What we find that 75% of the pine needles have elevated dioxin level near the location of the incinerator. We find high levels of dioxins, PCDF, in mosses. And what we also found was high levels of benzoapyrane, and that is the most toxic PAH in mosses near the incinerator. And also a very a remarkable finding is the finding of high levels of PFAS, the polyfluorinated alkyl substance in mosses. And then the eggs, 83% of the eggs exceeded the European limits of safe consumption of eggs. And 33 of the eggs exceed the European action limit for dioxin-like PCBs. And even one egg location exceed the European limit for dioxin PCBs with a factor 4. And if you go to the results in Madrid, we find 75 more dioxins, PCDF, in pine needles near the incinerator, and a factor 10 more PAH in evergreen trees near the incinerator. And a factor 20 more dioxins and a factor 50 more dioxin PCBs in mosses near the incinerators. And high levels of the dioxins were just found in the direction southwest. And we also did some analysis on eggs, and the eggs also not comply the European limits of dioxins and dioxins PCBs for safe egg consumptions. And the patterns we found in the eggs resemble those of the waste incinerator just we have found in the Netherlands. And here are the results in the Czech Republic. So we also find dioxins with factor 3 in the pine needles, and also find high levels of benzoapyrane, the PAH, in pine needles. Also high levels of dioxins, and that's also very strange, of remarkable, the PFAS in mosses. The eggs were about 89% of the eggs don't comply with the European limit for dioxins. 50% of the eggs don't comply with the European limit for safe egg consumption. And 75% of the eggs breaches the European action limit for dioxin PCBs. And what we also find were high levels of PFAS in eggs. And the same like the other, the congener patterns, so the patterns of the dioxins and the furanes are the same as we have found in the waste incinerated patterns in the Netherlands. Here we have a comparative scale of mosses, because we use in this research a bioassay, and the reason is that chemical analysis is too limited to follow all the different compounds. And bioassay is measuring the total toxic effect. And that's why we have use our own scale, and this is our result of our analysis in all kinds of places in Europe. And then you see at the right side the very high level of dioxins found in the mosses in Madrid, and at the left you see a green spot, and that is the reference site of in the north of Madrid, in a very rural situation. And this is another site of PFAS. We have done the PFAS analysis with a technique, the Fitch T4. We find very high levels of PFAS in eggs, mosses, in the cupresses, the evergreen trees, and in pine needles. And even in the eggs, we find high levels of PFOA. And if we compare it with for example, the European Food Safety Authority, we find levels about more than 1,000 times more than it would be for safe consumption. We have discussed this with other scientists, because this is alarming. So we have done this in Kaunas, in Pilsen. We have done also biomonitoring research in Paris, in Madrid. We have done also in Basque Country, in Spain, in the Netherlands, and we do this also in Belgium, in Beringen. And there is one thing that they all have in common, and that the official reports state that dioxins, PCDF emissions from incineration comply with the European regulations. And that brings us to the next step. Rules of representative sampling. What does the European Commission say about sampling? What about heterogeneity? It's a serious issue, because grab sampling is unacceptable. And the theory of sampling, this is the basic norm of how do you make representative sampling, is how to counteract heterogeneity effects when you're sampling, because all samples for analysis must be representative. And we just show here at the downside graph of the percentage of tag of dioxins PCBs, and that's are the group of compounds not measured at all in the stack, but you see how it's a dynamic form, and it changes all the time, and it can be up to 25% of the toxic equivalent of dioxins. And this is what is going on. It's in the European regulation, it is 2 times 6 to 8 hours sampling a year, and that means it's representing only 0.14 a year. So this mandate is an extreme grab sampling in time domain. How can heterogeneity of waste content, a serious issue, be counteracted by only 0.14 a year? And by this way, the European regulation protects the industry, not the environment. So we have done in the Netherlands, we have done parallel measurements with short-term measurements, what is regulated, and long-term sampling, about 256, and even 1 month, 690 hours. And then we see an enormous difference. We see a difference about a factor 460, and even a factor more than 1290. So that makes a big difference if you measure only such a short time. And then it's another point, and that is the pre-announced. All the sampling are pre-announced, and pre-announced sampling of waste combustion can never be representative. The sampling is only taken under ideal production conditions. When there is on the sampling something going wrong or a malfunction, the sampling will be skipped, and that's very strange to be representative. I have show here the latest result on dioxin emissions in the Netherlands, in the RAC 2021. And you see at the left side, all the results are below the detection limit. So it means that these figures form the base for the emission registration, national for the electronic pollution registrations. But it is based on not measuring any dioxin at all. So this is a very low standard, and and that's why in all the graphs you're showing, it seems to be that the dioxins are nearly gone away, but it's just taking how do you measure dioxins. And this is the same what's happening with the very toxic heavy metals. Only measurement a very short time a year. It is not representative. And another point is that the dioxins emissions are not only on dioxins, because there are a lot of other substances who needs to be regulated, and that are what I already thought are the dioxins like PCBs, but also the polybrominated biphenyls, the polybrominated dibenzodioxinefuranes, the mixed halogenated dioxins and furanes, the polybrominated diphenyl ethers, the polyaromatic hydrocarbons, and the PFAS. And as last one, because there are so much substances, chemical analysis is hampering. We cannot measure all the PAH, we cannot measure all the PFAS. That's why it is a strong recommendation to use the application of bioassay measurements to measure the whole of the toxic equivalent of these structures, because there are really too many substances to be analyzed on a chemical way. And then we go to the other than normal operation conditions. The shutdown and startup procedures implicate high levels of dioxins. The RSA Harlingen incinerator counted 30 shutdowns and startups in a space of 4 years. And when there is a shutdown or startup, that can be hundreds, sometimes even 1,000 times higher than a normal annual emissions. And we measured that several times. It's a really very high dioxin emission. And if there are excluded in the emissions, you're missing the most part of the emissions. And special care is during the cleaning action of the incinerators. It's a very unlighted procedure of cleaning of the incinerators, but with the combustion, a lot of dust is clotting in the inside of the incinerator. And to clean it, they have all kinds of procedures, like what we have shown here at the left side, that it's called the shock pulse generator. And then they make a kind of explosions inside the incinerator to fall down the dust inside of the incinerator. We have find that when we were measuring with the AMESA, the semi-continuous measurements, that when they use this kind of operations, the sample of the AMESA will be completely blown away. So 3 times our installation of measurements was destroyed by this kind of cleaning. And the incinerator said that it was an accident, that a gas flash was exploded, but in the end they comes with it, yes, but we just were cleaning our installation. So take care of it, and also take care when they doing this. In the Netherlands, they when they have done this explosions to have that clot from the walls, they blow this dust out of the incinerator, who is bypassing the back filter, just because they say, yeah, then it's going to be a dirt, and a back filter is very expensive. But this dust is very toxic, so never bypass a biofilter. It must be never be done. So we come to our recommendations. Please do semi-continuous measurements. Measurements should include the other than normal operation conditions, analysis on a broad scale of POPs. All emission results should be published, and a EU regulation must protect the environment, and independent biomonitoring of the environment. That last one, because in the Netherlands, the biomonitoring is paid by the incinerator by itself. It really must be independent biomonitoring, otherwise it's not representative. So we must urgently revise the rules of emission monitoring for waste incinerators to protect people's health and safety. Thank you for attention.
Thank you so much, Abel. This has been really a truly eye-opening report, and its impact has gone far and wide. I need now to remind you all that this report is fully available in the library section in the Zero Waste Europe website, and we invite you all to download it and to give it a read after this event. But for now, I'm sure that our panel and our audience are eager to discuss these findings. And so most importantly, discussing what can be done to address the pollution from waste incineration and make sure that it is in line with the EU zero pollution strategy. So in addition to Maria Soraya Rodriguez and Abel, we are also welcoming to this panel Benoit Zerger, who is the team leader for industrial emissions at the C4 unit on industrial emissions and safety for the DG Environment at the European Commission. Hello. Basileos Rizos, the head of sustainable resources and circular economy at CEPS. Hello, welcome. Peter Hebhardt, the Executive Director at the Engineering Office for Environmental Protection Technology. Hello. And Anne Ballinger, Principal Consultant at Eunovia. Hi, and thank you so much to all of you for being here today. We will start with a quick reaction from Benoit on this issue, on the context of the upcoming revision of the Industrial Emissions Directive. And then I'm going to give the floor to each panelist to follow up with a couple of minutes to express your views. Right, so the floor is for you, Benoit.
Okay, thank you very much, Maria. Do you hear me?
Perfectly.
Yes. Okay, so first of all, I would like to thank very much Zero Waste Europe for organizing this event of today and having invited the Commission to participate. Of course, I thank also Toxico Watch for their report and the presentation they gave just right now. Generally speaking, I would like to say that the Commission is following very closely the result of environmental monitoring. In this sense, the report drafted by Toxico Watch is very useful for us, because it complements information which is already reported via reporting schemes, for example, for industrial emissions or air quality. Maybe just to set and remind a bit the context. So the main regulation for emission for waste incineration is the Industrial Emissions Directive in the EU, which provides minimum environmental requirements for waste incineration, including an emission limit values for emissions of dioxins and furans to air from waste incinerators. But most importantly, waste incinerators in the scope of Annex 1 of this directive have to operate in accordance to permits based on the use of best available techniques, which are described in Commission implementing decision. So these are also secondary regulations. So while the minimum standards set in the ID, Industrial Emission Directive itself, are already very strict, notably regarding dioxin and furan, this recent document called BAT Conclusions include even stricter requirements. Here, I think we answer to a number of conclusions mentioned by others in this report. So, for example, we have more demanding emission levels for toxic and persistent organic pollutants, such as the dioxins and dioxin-like PCBs. We have improved sampling procedures now in this BT conclusion, including long-term sampling for emission or gain of dioxins and dioxin-like PCBs. And we have also monitoring for other than normal operating conditions in the same document. So a number of, let's say, concerns raised rightfully by Abel in this conclusion. Waste incinerators are starting operating after the publication of this BT conclusion. It means December 2019, have to comply immediately with this new requirement. Other waste incinerators, so which were existing before this BT conclusion, have to comply by the end of 2023. In addition to this, we have, of course, analyzed very deeply the report provided by ToxicoWatch. And now we're in contact with the member states' national authorities to verify if the concerned permits complied with the ID and if they are being reviewed to reflect the provisions, so the stricter provision of the BAT conclusion before the end of 2023. This is something now that we are in the process of doing. And in addition to these contacts, we plan also now to organize an exchange of views between the experts of member states to better understand whether similar observations are made elsewhere, and not only in these 3 or 4 cases which are part of this report. We hope these exchanges with the member states may also help in providing some complementary information that would contribute to drawing conclusions on the impact of emissions of dioxins, furans, dioxin-like PCB for the concerning incinerators. So this was on the specific case, let's say, on these incinerators, but maybe on a wider note, and to finalize my intervention, I would like also to mention that the Commission now intends to adopt a proposal for revising the Industrial Emissions Directive. And it should appear normally in early April 2022, so 1 month from now. This is to contribute to the European Green Deal and to the Zero Pollution Action Plan of the European Commission. It examines options how to make rules on industrial emissions fully consistent with climate, energy, and circular economy policies, and with very increased focus on the idea on circular economy, energy efficiency, resource efficiency, but also the use of less hazardous chemicals, which I think is very relevant in our case. So I think that's it for me for the moment, Marielle, but of course I'm happy to further intervene later on.
Yes, thank you. There will be question afterwards, I'm sure. Thank you so much, Benoit. I'm going to give the floor now to Maria so that you give us your perspective as a member of the European Parliament. Thank you so much, Maria.
Thank you. It has been a pleasure listening to Mr. Abel Arkenbout and Mr. Benoit, and it is very, very, very interesting. I have noted down 3 points that the Industrial Emissions Directive should take into account. I think first, a mandate continuous measurements of chlorinated and brominated dioxins, including under the other than normal operating conditions, such as stop-ups, shutdowns, and technical accidents. Second, it should also mandate regular biomonitoring for all existing incineration projects across Europe, to reassure communities living near waste incinerators about the health and safety risks of all operation stages and incinerator. And finally, the EU should promote and fund circular, healthy, sustainable alternatives to waste incineration. Thank you.
Thank you so much, Maria. I would like to give the floor now to Basileios, that comes from CEPS, one of the leading think tanks in Europe. So Basileios, it would be great to hear your perspective. Thank you so much.
Absolutely. Thank you very much. Hope you can hear me well, first of all, because I understand
Perfect.
Okay, very good. And very happy to see so many participants also from around the world, actually, which is, it shows the interest around the topic. So starting from the biomonitoring research results in the presentation, I read with interest some of the aspects of the reports, the ones I could technically understand, let's put it like this. And I also the presentation, I think that this is very insightful and useful. Now, of course, to some extent, it is difficult for me to go into the very technical details and assess them, but I think that such contributions are very much welcome, given that there are still quite significant research gaps in the domain of health impacts of incinerators. And that's not really my conclusion, but a view that is also shared by various research papers. So I did some readings in the last few days, also in preparation for the event today. And as an example, I came across a large peer review assessment on the health impacts of waste incinerations, which looked into evidence from different studies across the globe, including Europe. And one of the key conclusions was that there are significant gaps and inconsistencies in the available evidence, which indicate basically that an extra degree of caution should be paid on the health impacts of incinerators. You can look the paper up. It's called the Systemic Review of the Health Impacts of Incinerators, and there are many more. So certainly such evidence is very much welcome. So now perhaps, you can allow me to give a little bit more the broader perspective and how I see the incineration, the role of incineration in a circular economy. And I think that's a question that has emerged since basically we started debating about circular economy in Europe. It's almost 10 years now. So there's a lot of discussion about what role of incineration, if there should be any role of incineration. And I think discussing about the role, I think first of all requires a space for discussion about what the long-term ambition is. How do we define circular economy? Where do we want to end up in the coming decades? And of course, we don't have one specific quantitative target for circular economy because it's a complex concept. We'll see what we'll be having in the future, if there will be ever one specific target or indicator. But at the moment, there is by the European Commission the monitoring framework on the circular economy, which consists of 10 indicators, and some of them are actually broken into some sub-indicators. So there is a framework, but in general, it is a complex task to say where do we want to be in the coming decades. But irrespective of the complexity and what we want to achieve in the long run, the available evidence and indicators that we have at the moment show that the current model in Europe generates significant quantities of waste. And basically, municipal waste generation has been increasing, as we also heard earlier. Now, if we look into specific waste streams, the picture doesn't look very, very good either. Looking into plastics, for example, which receive also a lot of attention in the discussions around incineration. Between 2009 and 2019, the volume of plastic waste increased, I think, by 24%, if the figures I found are correct. Projections, if you look into the literature, there are very many projections on plastic waste generation in the future globally, but also in Europe. They don't look very promising either. So in a nutshell, in practical terms, we are very far away from a circular economy, whatever circular economy definition we might use. There are significant quantities of waste produced, and of course that gives rise to the argument that given the current situation, incineration still has a role to play as a better option than landfilling. Now, this relevance of incineration, of course, will not be indefinite, and especially if we are to omit any of the ambitious zero carbon and zero pollution objectives. So there will be a point where this relevance will decrease significantly. And here comes the challenge, because any investment in new incineration capacities, especially in countries that have very high landfilling rates, and I know that in the south, in the waste management plants of some countries, there are some new incinerators are even foreseen right now. So any kind of investments of this kind should not prolong us reaching this point, tipping point, if you allow me. Now, the question is at which stage and when incinerators will become much more relevant, and that will depend on a variety of factors, and a key factor or driver, if you allow me, is policy and EU regulation. And we have ambitious recycling targets for 2025, even beyond. Past experience at the same time has shown that targets alone are not enough to systematically transform the waste management situation in the country. We've seen in the South, for example, we have waste targets, but still many countries still show very high landfilling rates. So targets are not enough. And what we need is an overall policy mix in place. And that policy mix, of course, goes sometimes beyond traditional waste management policies that drives the transition towards a new model. And within such a policy mix, of course, any potential trade-offs between policies should also be addressed. And just to give one example here, we accomplished a study recently on electronics. And one of the issues that we identified was that recovered plastics from electronics suitable for recycling according to the EU rules often ends up in incinerators just because it's very difficult for recyclers to deal with the complex administrative requirements stemming from EU chemical legislation. That's one of the few trade-offs we have identified. So getting the overall policy mix right is really key to achieving a transformation change and support reuse, recycling, prevention over incineration. Then, of course, implementation of waste legislation is important as well. Another observation of our study in electronics was that according to some actors, there is incoherent implementation of the waste electrical and electronic equipment directives principles across member states, leading to different collection and recycling schemes. And that can also end up, let's say, demotivating recycling suitable streams ending up in recycling bins and then instead ending up in incinerators. Now, in addition to targets, you need measures, of course, to push demand for recycling materials in the market. And of course, we'll be having recycling content targets under the Single-Use Plastic Directive. Fee modulation, exceeding producers' possibilities, another example. Financial incentives for recycling, which we have seen in some member states, can also play a role. So there is a combination of policies that can drive the change. And then, of course, innovation will play an important role here as well. And I see two important areas. So the first, of course, is innovation in post-collection separation techniques and technologies. And what we hear sometimes from some waste management operators is that even in countries with very advanced collection systems, there is contamination of collected material due to the mixture in bins of different materials together. So there is room then for innovation, for new techniques to ensure that even small quantities suitable for recycling, end up where they're supposed to end. And the second area refers, of course, to alternative recycling technologies. And I heard earlier this point raised up. We know what could be the alternatives for incineration, and then a new discussion, a large discussion opens up. And there is a range of technologies. One of them, I think, that receives a lot of attention is chemical recycling. But even these technologies, they bring a whole other debate about the potential environmental benefit risks. So we need more evidence, more clarity, and also a new discussion, where these technologies fit in the future waste hierarchy. So finally, and to conclude, in line with what I discussed earlier, you basically need policies and a policy mix that addresses the heart of the problem. And I think it is very well known today that just having the right bins in place, putting the material in the right bin, even having good sorting techniques will not be sufficient to just drive decarbonization and zero pollution targets, given the really high rising trends in waste generation. So we need policies that really address the heart of the problem. That's in a nutshell, and maybe we'll come back later.
Thank you so much, Vasileios, for your insights. Thanks again. I would like to go the floor then to Peter. If you could give us your quick reaction as someone that was directly involved in the discussions around waste incineration, best available techniques, reference documents. Thank you for being here, and the floor is yours.
Thank you very much, Marielle. From my point of view, the results of these studies and investigations are extremely interesting because they show partly very high concentrations of POPs in the vicinity of the considered plants. But from my point of view, in some points, the measurement data raise some questions as well. In the case of the plant near Madrid, the correlation between waste incineration plant and the contaminations seems for me to be clear. Here it's absolutely clear. At the plant nearby Pilsen, still in a distance of around about 5 kilometers away from the plant, increased values in X were found. And this seems to be for me, quite far away. So here we have to look at maybe additional reasons very carefully. The highest result should be expected in the northeast due to the wind direction, the windrows, but in a distance of 1.5 kilometers, the analyzers were normal. And probes in pines and moose as well. Here, the results are, for me, not so clear. And coming to Kaunas, the plants in Litauen, 3.3 kilometers against the main wind direction, high concentrations in the X were found. And this is something which should be really confirmed. The other X results correspond with the main wind direction, and here I see a clear correlation with the waste incineration plant. So from my point of view, a great lack of this study is that there is very less information about the plants itself. Only for the plant in Madrid, information is available for the waste gas abatement system. For the other two plants, there is no information there. And in further reports, this should be added because it's really important. So we do not know if specific pop abatement systems, for example, AC injection or moving bed filters are in operation. We also know nothing about the ELVs of these plants, for example, for dioxins, and we know nothing about the techniques applied during startup, which is extremely important. We don't know if there are, for example, bypasses installed at startup situations, or is there preheating before the fabric filter to abate pops during startups. These informations are really, really very important. And for example, if no abatement system at all is in operation, the high values are not wandering for sure. Yeah. I worked in dioxin emissions and waste incineration plants for many years, and I was able to bring in the breath this knowledge in, and the results are but 5 for to measure at startups as well, and also but 18s which refers to the OCNOC situations. And the results of these investigations in Madrid, Pilsen, and Kaunas show how important these provisions are. Unfortunately, we not achieved that quasi-continuous measurements, for example, with AMEDA, have to be carried out. This is really a lack of this bad paper from my point of view. More than 10 years ago, I was involved in a study of Öko-Institut, a well-known German environmental research company, and we regarded a hazardous waste incineration plant in Bavaria, in Germany. And in the vicinity of the plant, biomonitoring at several monitoring points, it was more than 12 or something like this, with standardized cultures of grass and green cabbage, were brought out, harvested, and analyzed over several years. And the results showed that especially PCB concentrations were much higher than background values. And we looked very deeply into the results using statistical methods as well. And in the end, we came to the conclusions that not the hazardous waste incineration plant was the pollutant, but a shredding plant located directly nearby. And my experiences with other shredding plants, I made similarly, I saw similar high concentrations in the vicinity. And to be honest, I remember very well the environmental group in nearby this plant in Bavaria didn't want you to hear that. Sorry. The results of this monitoring show absolutely clearly, from my point of view, that there is at this plant something massively rotten. I assume that this is in many other plants in Europe the same. Maybe a little bit more seldom in Belgium, where we have, for example, AMESA in operation normally. in France, Germany. But from my point of view, there is an absolutely strong need to carry out measurements, for example, with sorbent sorption systems like AMESA, like it's currently done in Belgium and partly in France, a few cases in Germany as well, but very few cases. Even, and this is really, really important, even when no waste is burned, like in startup situations, to make sure that the pop abatement techniques are in operation all the time. And from my point of view, dioxins can be used as a lead substance for other pollutions like brominated dioxins and benzoapyrene. And for sure, biomonitoring can be an additional method to monitor POPs in the vicinity. So thank you very much.
Thank you so much, Peter. Really interesting remarks, and I'm sure later on Abel will have a chance to answer some of the questions that you raised. We're going to move on now, giving the floor to Anne. Hello, Anne. Thanks for being with us today. Given your work on alternatives to incineration and the wider pollutant impacts of this type of facility, it'd be great to hear your expert views. Thank you so much. Hello? Yes?
Yeah. Sorry, just was
Okay.
a bit slow for me to unmute. Good afternoon, everybody. I'm very pleased to be here. So I would just start to, by reflecting on the fact that when we're talking about the context of alternatives to incineration, certainly as far as residual waste is concerned, this is, as previous speakers referred to, landfill is another significant option. And so certainly in a global context, it's these two treatment technologies that are really often being compared to one another in this context. And I think from that point of view, it's important to reflect that both types of technologies produce air pollution. And if you're going to look at in pollution of this type from incineration, you shouldn't discount the possibility that there are a very large number of organic pollutants also being produced in landfill as well. So we do need to be quite careful when we're thinking about alternatives from the residual waste point of view, because both of these technologies cause problems. There is a lot of uncertainty around the extent to which these various technologies actually cause harm to health, as was referenced before as well. But there's also some clarity on some of the pollutants that do cause problems. This is particularly true for incineration as far as NOx pollution is concerned. So even though there are some uncertainties that I think you'd still want to unpick and address, we can already be clear to a certain extent that there are potential problems that arise from these facilities. So for us, it's quite important to see residual waste treatment in the wider context. And as was reflected before on various speakers, we see this in the context of what you need to do to address other environmental problems. And in particular, climate change is one of these. So I think from our point of view, if we want to be consistent with meeting net zero targets as far as climate change is concerned, all forms of residual waste treatment are problematic. You need to do something. They're not consistent as they're currently operated to meet those targets. So clearly, if we also have this problem alongside this with issues like persistent organic pollutants, then we have the possibility of potentially treating both of these problems together. The main way in which industry is responding, certainly in the UK, where I'm from, as far as climate change is concerned and meeting net zero targets for incinerators, a key component of this is carbon capture and storage. But obviously, if you went down that route, then essentially you would still have the problem in a lot of cases with these pollution problems still being there. So really, the only way we need to tackle this is, at least in part, to look at how waste management systems can be used to decarbonise the economy as a whole. And if you're going to do that, then you clearly do need to focus your effort as much as possible on waste prevention and also on recycling. And in this context, you will therefore reduce the potential problems that you have with pollutants in the residual waste treatment system anyway. So for us, this will be required whether your current prevailing residual waste management system is landfill or incineration. Both of these options are problematic in the longer term. So I think for me, I'm reflecting on the very interesting outcome of this study that was presented today. It seems very clear that better monitoring of these pollutants is needed because there are uncertainties and gaps in the evidence base, and that definitely is going to help. But in the longer term, we need to look at waste management in the context of circular economy. Otherwise, we will fail to meet net zero targets for climate anyway. And that's clearly going to give us definitely a lot of other problems to consider on top of the ones we already have today that we know about.
Excellent. Thank you so much, Anne, for giving us this wider picture. So, and thank you everyone in the panel. So we will open now the floor for questions from the participants. That actually many people have already been bringing forward many questions. Thank you so much for your enthusiasm. I actually will kick us off with a couple of questions from my side. And the first one is for Benoit. So the question is, how can the revision of the Industrial Emissions Directive reassure the communities living nearby incinerators about the safety of those facilities? And one question that has also come up in the Q&A, should biomonitoring be made mandatory for all existing incinerators? Benoit.
Yes, well, thank you very much for your question. Well, generally speaking, to answer your first question, the revision of the ID will look at increase the effectiveness of the ID in various matter to make, let's say, to make it more efficient. Concerning biomonitoring, well, this is clear that the report from Toxico Watch shows that there are high levels of pollution in biomarkers. This is clear. Now the question is, should we have a systematic biomonitoring around each and every waste incinerator? I think this is something we need to address very carefully, because we cannot take such decision before we fully understand the link between what was found, I think, in this report and the emission from waste incineration. I mean, for this, for example, do you have information or potential other sources of information of emissions, for example? What is the correlation between biomonitoring and the emission from waste incineration? So there is a certain number of questions that we need to address first and understand fully before we can decide on such a systematic approach, not mentioning that in some cases, a local approach and at national level can be more efficient because member state authority may be a better place to address the specific cases. So this would be my answer to get first a better understanding of whether there is a problem and to which scale we have the problem before we can assess an action at EU level for biomonitoring.
Okay, thanks so much, Benoit. I have now a question for Anne and Peter about the measurement of this pollution. So should the regulatory limits for pollutants be set not only in terms of the concentration, that is the amount of dioxins, the amount of nanograms of dioxin per cubic meter of air that comes out of the chimney, but also be measured in absolute value, so that incinerators, because incinerators stay in the same area for several decades. And if so, what would be this maximum value that the environment can take without impacting animal and human health? Like, for example, the Ivory incinerator in Paris has been burning 700,000 tons per year for 50 years. So even if the pollution coming out of the chimney would have been below the EU concentration limit, over the course of those 50 years, this has obviously led to excessive levels of dioxins in eggs and vegetation. So what does this tell us about how we measure this pollution and how should we set this up? I don't know, who of you would like to go first, Anne or Peter? Peter, perhaps? Go for it.
Sorry, ladies first.
Sure. Anne?
That's not fair. This is actually quite a difficult question to answer, I think. So I can see the merit in a longer term a longer term appraisal of how you would look at the impact in a local area. I don't know how you would do this from the perspective of actually setting a limit based on the knowledge that we have now, because I think, as the speakers have mentioned, that there's actually a lot of uncertainty about the impact of these pollutants on health and on the local environment. So I don't think we have a current research picture of exactly what a safe limit would be for these things or what could be permitted. And my suspicion is that the knowledge of that would change over time. But certainly having some kind of better understanding of limits in terms of the emissions per meter cubed, as you suggest, is definitely something that should be looked at in more detail. But I think you would need to start by having better monitoring frameworks in place, so you've got some idea of exactly how much this is a problem anyway. Because as I think Peter alluded to in his answer before, actually it's quite difficult to look at emissions from one plant in isolation in a local area, because you have a lot of other potential contributors to that problem in those local areas. So a study like this is very interesting because it certainly suggests that there could be a problem, but it isn't enough by itself to actually really bottom out the extent to which that one facility is the problem. So I think that, it definitely seems to merit further monitoring activity, which it sounds like the European Commission is already firmly anticipating. But the extent to which you could set further limits and certainly look at the longer time frame now based on the evidence base, I think is much more difficult to ascertain.
Yeah.
Thank you.
All in all, I can agree with Anne. I think measuring the concentrations is the most important thing, and absolutely mass flows. How can you regulate this? I think it's a little bit difficult and complicated, and we must assure that really low pop concentrations occur at the chimneys. The problem are the odd knock situations like startup. The problems are maybe when, I don't know, when abatement system is not in function at all. Yeah, these are really the problems, because then a waste incineration plant emit factor thousands or more than under normal operation conditions when the abatement system is full in function. So I think this it doesn't help to regulate here more than concentrations. And I cannot say how big the mass flow of dioxins or POPs have to be to really ensure the environment around. These are questions I can understand, but they are extremely difficult to answer.
Okay, thank you so much. I have a question for Basileios then. What do you think needs to happen to move away from waste incineration and promote and fund a circular, healthy, sustainable alternatives to waste incineration instead?
Good question, Marielle. And yeah, I think I incidentally alluded a little bit on this in my initial remarks. And as I mentioned in the beginning, I think having a policy mix, first of all, Europe has a history of policies on waste since, 35 years ago, a history of 7 environmental action plans. So a lot of policies, which of course they have made a positive contribution, but still, if you look into the details of some waste streams and incineration and landfill levels, there's a significant gap. Now, you could argue that there is a window of opportunity. We have like an ambitious circular economy package. We have a sustainable product initiative is going to be published in the end of the month. For the first time, we discuss about measures such as public procurement mandatory criteria, eco-design rules for non-energy related products. So really policy measures that can make a difference. But my key point here is that you need a policy mix that avoids contradictions. And I gave a couple of examples during my presentation. I mean, there are more of these examples actually. I understand that this is a complex issue that cannot be addressed by one piece of legislation. But at least some level of coherence should be achieved, and that's not something new. Of course, there have been efforts in the past as well, but still, such issues should be taken into account. Now, when it comes to incineration here, I would like to comment that, of course, whether incineration or another option will be used, it depends on a variety of factors, and these are, of course, historic infrastructure, price, geography of the country, policies as well. And not every member state is the same. And that's something we should keep in mind. For example, the Nordic countries or countries like Greece with many islands have a related scattered population, long distances that has an impact on transportation cost of waste. Plastic waste, which is often discussed in the context of incinerations, has a relatively low density compared to other types of waste, while at the same time has high volumes. So there are transportation costs involved. So these are factors that should be taken into account when countries are making the waste management plans. But in any case, one fit solution for everyone will not be applicable even in Europe.
Great. Thank you so much, Vasileios. All right, I'm going to take questions from participants. I'm going to pass them on. And I would like to start with questions that have been raised that I think it's appropriate for Abel to respond. So there is a question that asks about what concentrations did you measure at the stack for PCDD and FTQ? Do you know the operational hours of the incinerators? And another question is about the context of the incinerators. So it asks, have bonfires, household chimneys, and other dioxin sources have been taken into account in the study in the case of Madrid? Because the participant says, I know the plant is located in a very deprived area. And feel free, Abel, to address other questions that have been raised before, if you may.
Okay, a lot of questions.
I know.
Okay.
Giving you hard work today.
Yeah, okay. The first question was about the TEQ. What did I measure for the TEQ in the stack of the incinerator? I understand.
Yes.
Yeah.
It said, what concentrations did you measure at the stack for PCDD/FTEQ?
PCDD, yeah? F. Yeah. Okay. We have measured in a stack about more than 20,000 hours, inclusive some start-up and shutdowns. So we have measured sometimes a very high level of a PCDD tags, about nearly 2 nanograms of a TEQ per normal cube. So that are high levels. You understand a little bit, or okay? Yeah,
sure.
Yeah.
Just
okay.
Go on.
Yeah, and the other question about Madrid, yes, we know it's. Yeah, I'm sorry to say, but it's a horrible place to be there. It's full of backyard burning, all kind of process. When you're looking on the Google Earth map, you see all places are burned. We know that it's happening, but we couldn't take that in account. We have only looked to the continuous patterns in the X, and what we saw in the X, that the patterns remarkable were a little bit the same like we have found in the Netherlands near the incinerator. So most of the time when you do backyard burning, you see patterns of furans in the X, and we didn't find that. But I think we need more examples of X to take in that area, because it's a problem. There are a lot of confounders in that area. Yes, I hope I answer all the questions.
Yes, and if you want to address any of the points that Peter raised as well, feel free to respond in your own time.
Oh, okay, yeah, because it was an interesting point what Peter was saying about the biomonitoring in Germany. I heard about it, and we have also done some biomonitoring with metal scrapping, not only in Germany, but we did also in some East European countries. it's a problem also in Belgium, near the border of Paris. Metal scrapping is really a big problem. Yes, and you have right. That is a point we need to address. Thank you again for that point. Yes, but in this study, we try to focus only on waste to energy facilities, because I can mention also, for example, biomass incinerators. We have found also a lot of problems near that. So step by step, first waste to energy. Okay, thank you, Peter. You must.
I'm so sorry. Thank you for flagging that. So thank you, Abel. And next, I have a question for the European Commission. So Benoit, a participant says, do you consider introduction of limit for brominated dioxin emissions? And the person also says, I'd like to also hear why the EC suggested limits for dioxins in waste so high that almost non-waste incineration fly ash should be cleaned up from dioxins and will be allowed to be potentially used, for example, on remediation projects, so-called sometimes recycling of fly ashes, so that there is no control on dioxins spread. So starting with, do you consider introduction of limit for brominated dioxin emissions? Benoit?
Hello?
Yes, we hear you now. Thank you.
The button to click on. Well, how does it work? The introduction of new limits in VAT conclusion, so in secondary regulation. It's not a commission which decides in this ivory tower to put one day one limit on one pollutant. It's a long process which involves industry, of course, member states, environmental NGOs, and it's based on data collected from industrial plants, existing plants. So this is what drove the issuance of these VAT conclusions in 2019. And of course, this is let's say, a living process. So next time we will review this graph, of course, we will take into account the information which is available at that time to derive whatever levels are necessary or can be derived at that time.
Okay. All right. Thanks, Benoit. Okay, I'm going to follow up with a question for Anne. So the question is, if for a moment we put aside the very important problem of fossil fuel-based CO2 from burning plastics, is incineration inherently a problem? Is it that we cannot scientifically stop toxins from going into the environment? Or is it that we not done politically or economically organizing our incinerators to have all they need to catch and chemically change these molecules? Or is it a bit of both?
So I'm not sure I totally. Could you repeat the second part of the question? Actually, the bit at the beginning with the fossil CO2 plastics, I understood. So the point at which you said scientifically, repeat the bit that follows.
Is it that we cannot scientifically stop toxins from going into the environment? So technical, is it that there is no technical solution, or is it that politically and economically it's not possible to provide these incinerators with everything they need to actually, be safe?
Okay, yeah, understood. So I think it probably is a combination of both. So both Benoit and Peter have talked about the Best Available Techniques programme, which sits behind a lot of the legislation, as I understand it. So this tries to, I think, to a certain extent, bring together the political, economic aspects, along with the extent to which technology can actually resolve these problems. I think that there will be, it is impossible to completely eliminate pollution from these these facilities. In the case of the dioxins, this is not pollutants at the moment that we even properly understand the extent to which they're being emitted. So I don't think that achieving completely zero pollution is going to be potentially something that can be achieved. What happens in the balance of operating these facilities is you try to reduce this harm down to a level that is assumed to be acceptable. And for some pollutants, actually, there is no sort of level agreed that will be completely harm-free. So this is true for particulates. So across the whole of the industrial emissions directives, not just incinerators, this is affected by. I think there will always be limits where you won't be able to go beyond a certain point to reduce it at any cost. But what we decide as a society is the extent to which we can accept that. And this is where it comes back to the idea of, well, what is actually a safe limit? What is healthy? What do we want to accept as a society in terms of those limits? And given that we don't fully understand all of the impacts associated, particularly with the pollutants that we are talking about today, actually, with the state of knowledge we have now, I don't think we can answer those questions, which is one of the reasons I think why we do need to look at alternatives where it is likely that the level of harm will be less, although there are still harms associated with this, as was mentioned earlier. So even recycling processes, you can still have some pollutants emitted in some cases, which can be potentially difficult.
Indeed. Thank you so much, Anne. I have a couple more questions for Abel. So the first question says, have you seen high amounts of dioxins from stop and startup of a waste incineration plant when you have used semi-continuous sampling with a sampling period of a month with no bypass of cleaning equipment? Did you get that?
Yeah, I think I understand the question. Yes, that we have monitored. Yeah, so we have monitored several times startup and shutdowns, and then we have found a lot of dioxins in our AMISA cartridge file. And we also have, when we do this measurement, this beside the AMISA cartridge, we also get the information about from the incinerator themselves about how the functionality of the air pollution control devices were. So about the effectiveness of the back filter, but also from the ESP and other kind. Also about the temperatures for the back filter, or the temperatures for the ESP, because also that is very important for the de novo synthesis of all kinds of dioxins. So it's a very complicated process, you know, to avoid any de novo synthesis of dioxins. But we have measured it many times, yes, especially during start-ups and shutdowns. And then you must realize that a start of a shutdown is when the whole installation is going down. But what we have seen is that the process of incinerator is not a continuous process. It's the temperature is going down, then it had to be again fueled again to be high enough, because you have also to do with the temperature in the post-combustion zone. It must be 2 seconds above the 850 degrees, and most of the time it goes down. So it's a very hard process for the incinerator to give the ideal conditions to destroy all the dioxins. And most of the time, it is not not to get at all.
Yes. Okay. Thank you. Can I give you a second question now that we are at it? The question is, how did you account for other potential sources of dioxin emissions? For example, the map showed that in the presentation show highways close to the sampling points of for transportation, and that accounts for 10% of dioxin emissions in the EU.
Yes, that's another. There are a lot of confounders, and we are now setting up all kinds of other biomonitoring researches, and that is before a new incinerator is built. We're going to do some biomonitoring before the incinerator will start, and then we making a mapping of all the possible confounders. We do like this, bijvoorbeeld in Belgium, where a lot of industry is there, who also pollute the dioxins. So we take in account also before, for example, in Madrid, you can see we have done some sampling of mosses near a road, and then you see an elevation of the dioxins, and you see it also in the patterns of the dioxins. You can read what is coming from that possible source of a road. So the road emissions are indeed also a confounder.
Okay, thank you so much, Abel. I have a question for Peter. So the question from a participant is, what would you propose as regulatory policy recommendations to minimize dioxins, PCBs, furans in the atmosphere?
The answer is easy, because I mentioned before, especially in case of waste incineration plants, we not only need low concentrations in the stack, but we need to monitor it all the operation time, really all the operation time, because some situations are crucial. And I agree with Abel, and have another example. A couple of years ago, or many years ago, I was involved in a permission process for a waste incineration plant, and we achieved that in the permission that the AMESA system, this classic continuous sampling system, has to be installed. Yeah, and a couple of years later, we asked for the results, and they said, we installed it, but we didn't have to use it. But then measurement results were available for a couple of years, and we saw absolutely clearly in month probes, in every month probes, where a startup occurred or happened, the concentrations were quite high, and in month probes where no startup occurred, the concentrations were far below 0.1 nanogram per cubic meter. So these startup situations are really extremely important.
Yes. Okay, that's good. Thank you. I have a question now for Benoit. So it says, with waste incineration excluded from the EU sustainable taxonomy, and now the findings of this study, how will the European Commission ensure that EU countries will not support financing of new incinerators in global south countries through including technical assistance, for example, and meaning global south, like outside the European Union? I'm afraid you're mute.
Well, indeed, it's a quite difficult question we're asking here now. So I'm not sure I will have an easy answer, but I think you're right. This is something which needs to be considered at a global level. So if you wish, I can try to find more information to answer this question later on, but right now it's a bit outside of my scope of competence, but I can find some information if you wish so.
Yeah, sure. Thank you. That'd be great if we could follow up after the event. It's definitely, you know, us being part of a global network, definitely there's many groups in the global south looking at Europe and how its impact into beyond the European Union.
Maria,
great.
Can I come in this one? Maybe
please go on, please.
Good. So basically, yes, it's true that the incineration is not covered by the EU taxonomy, which means that also the national recovery plans cannot include incineration capacities. That does not, of course, mean that incineration is not is banned or forbidden. So national governments can find other means to finance incinerators. And that brings for the European South and for the global South, of course, the question, as I explained earlier, where do we draw the limits and how these limits could be drawn? What I can say here is that what is needed is that national waste management plans that are ambitious enough, and that's not something that we always see. So in such plans, the option of waste prevention and recycling should be the first priority, and that's not always reflected in these plans. And then to be realistic, for some of the volumes that, especially for countries with very high landfilling rates, for some of the volumes that will not be able to deal with other means other than landfilling or incinerations, to foresee some incineration capacities as well, with a clear plan and time horizon. So I think that's one thing that is missing. And yeah, from the Commission side, or let's say from a national expertise side, there's definitely several forums and initiatives that could also provide technical expertise exchange and advice to countries. But it also depends really on the member states. And then I would say that the national waste management plans have a key role to play.
Okay, great. Thank you so much for coming in, Basileos. And I think we are reaching the time when we have to wrap up. And so we are coming to the conclusion of our event. Thank you so much, each and every one of the panelists, for your presence today and your enthusiasm and all your knowledge and expertise. We hope that this has contributed to the debate on the need to revise the current policy, and that the Commission will consider these proposals in the upcoming review of the Industrial Emissions Directive that is foreseen in April. Special thanks has to go to MEP Maria Soraya Rodriguez and Martin Hoxis for their special support in the promotion of this event. As a final favor, as many of you will probably have seen posted across our channels, Zero Waste Europe is currently running an audience survey, and this is serving to better understand the needs and expectations of our different audiences and help provide better content accordingly. So we are dropping the survey link now on the chat, and we would be very thankful if you could spare some minutes after this webinar to fill it in if you haven't done yet, because your views really matter to us. And so finally, I want to give a big thank you to all our participants on Zoom today and on YouTube. It was great to have you here today, and I hope you enjoyed the discussion as much as we did. Thank you so much to everyone, and we hope to continue